Hello and welcome, Ebusiafo. Please, if you know you have not subscribed, try to subscribe for my YouTube channel. I'm trying to promote it. It's not easy, but every day I'm forcing. Make sure that you subscribe. Um, we are done with the equation with constant coefficient. We are now going to look at the equation of variable coefficient. Okay, so the equation of the variable coefficient, the procedures is a little bit different from that of the constant coefficient. The reason being that here you can't find the angle between them, just like the constant where you were finding the angle. Because here, like the example given here, you to find general solution of y(ux) plus uy equals u. Okay, though this one, the b here is 1, but here the a is y. So if b is 1, like this, you know a is y, right? B is 1. If that is the case, it means that tan alpha will be B over A. So tan alpha will be 1 over Y. So what will be the tan inverse of 1 over Y? You see? So when we have with a variable coefficient, you can't use the angle. So we need to find another way of doing this. Is that okay? Good. In fact, the new way of doing this is not something new to you. You know this formula already. So you know this formula already. So in this case, our A is Y. So I have the x over y equals to dy over 1. Okay, so here we are not interested in the du df. Okay, good. So this one multiplied this multiplied that you have the x equals to y dy. Is that okay? So in this case you can integrate it so that I have x plus c1 equals y squared over 2. Is that okay? So for this matter, or for this case, our c1 here will be y squared minus 2x. Okay, so this c, what you are going to do here is that you replace this c with xi or itai. That one, it depends on you, but normally we like using the xi. So you say that c should be equal to what? Xi. So it means that xi will be y squared minus 2x. So that's the procedure for the variable coefficient. When they give it to you, the c that you will get should be represented by xi or itai, anyone that you want to use. After choosing your xi to be this, now you have to get itai. How do you get the itai? For the itai is very simple. You can choose your itai to either be x or y, any of them. So here, somebody can decide to choose the itai to be y or x, but I'm using y. Okay, very good. Now when you are done with this, you then differentiate this with respect to x, which will give you 2x, with respect to y, which will give you 2y. I mean, this will give you negative 2. Then with respect, itai with respect to x, which will give you 0. Itai with respect to y, which will give you 1. Please don't be confused here. What I've done here is very simple. When it is variable coefficient, just like I demonstrated, there's no way that you can find the angle between them. So we use the method of characteristics formula to get c. There's no even need to bring c1 and stuff. Once you get a c, you equate the c to xi, sorry, or itai, depending what you want. I have used xi. If I equate this to c to xi, then I have to get itai. How do I get itai? The itai is getting by either choosing y or x. Any one of them works. Very good. After that, you differentiate them partial with respect to x, with respect to y, for both xi and what? Itai. That's what I've done so far. Okay. When you are done with this is what you are going to do. You have to look at this. Nowadays, I'll be going straight. Okay. If I write, this is a question given. Yux plus uy equals u. Okay. So this is a question given. So here I have my y bracket open. Now I'm writing this straight. Ux will be written as well. U xi x plus u itai x plus uy will be written as what? U xi y plus u itai y equals u. Is that okay? Very good. Now xi x is here. Xi x here negative 2. So we are going to replace this one by negative 2. Negative 2 times y is going to give you negative negative 2y u xi. Now itai x we have 0. So if I put 0 here, everything will be 0. 0 times y is still 0. So we're done with that one. You move to this place. Xy is 2y. Have you seen that? So this will give me 2y u xi. Itai y is 1. 1 times this will give me u itai equals u. So you realize that this and that are the same. They will go to 0. So this is what I have. U itai equals u. You know that here, if I differentiate by u here by u, I'll have u itai, or this will imply that u itai over u equals 1. So let me integrate this. You see, this is itai, means that I also integrate with respect to itai. So any constant should be a function of what? Xi. So this is a function in derivative once I'm integrating with itai. So this is what I'm going to get. I'm going to have ln u is equals to itai plus f of xi. Let me make it ln so that it will be easy for me. F of ln of that. Okay, very good. So here, let me bring this here. I have ln of u over f of what? Xi equals itai. Why am I using red pen? You take e on both sides, you have u over f of xi equals e itai. So it means that my u will be equals to f of xi u itai. Tell you anyhow. So this is what you are going to have. Now after getting this, we need to replace this xi with this and the itai with the y. So xi was y squared minus 2x. Itai was what? Y. Is that okay? Now, this you were to find what? The general solution. So we are done. Is that okay? We are done. If you are to find a particular solution, then we should have moved forward to substitute it here and get our particular solution. So guys, let's look at the example number 2. So you have to find the general solution of x ux minus y uy plus u equals 2. X is greater than 0 using change of variable. Okay, it has been stated clearly using change of variable. So that's how the exams will look like. In the exams, normally they will give you the method to use. If it is not given, then use any of the method that you think is okay to you. So here, because it's variable coefficient, we need to use this formula dx over a. In this case, a is what? X equals to dy over b. In this case, b is negative y. So when I differentiate, integrate I'm going to have ln x equals to negative ln y plus ln c. So my ln x will be equals to ln c over y. It means that if I take e on both sides, my c will be equals to xy. I say that the c should be equals to xi. So xi is equals to xy. Then you choose itai to be what? Y. You can also choose it to be x. But if you use x, you normally get some equations that is difficult to integrate it sometimes. That's why I like using the y. Now let's differentiate this with respect to x. That will give me y. With respect to y, that will give me x. But if you differentiate with respect to x, this will be 1 leaving y. With y will be 1 leaving x. Itai with respect to x is 0. Itai with respect to y is 1. Now let's write the equation. This is the equation. Xu x minus yu y plus u equals to. So here is going to be x bracket open u xi x plus u itai x minus y bracket open u xi y plus u itai y is equals to, plus u equals to. Okay, now xi x is y. So here the whole of this place will be y times x is what? Xy u xi itai x is 0. So everything here will be 0. 0 times this will also be 0. Minus xy is x. X times y is negative xy. U xi itai y is 1. 1 times this will give you negative y itai plus u equals 2. Is that okay? So this will cancel with this one. Okay. Now in this case, what we are going to have is negative y u itai plus u equals 2. So this is what we have now. Okay. So if you want to differentiate or if you want to solve this is giving us non-homogeneous, and for it to be non-homogeneous, you can use the undetermined coefficient or the integrating factor, any one of them. So what you are going to do here is that you have to divide through by the negative itai, so that you have u itai minus u over itai equals negative 2 over itai. Is that okay? So for this case, if you are using the integrating factor, mu will be equals to e to the power. So this will be what? Negative 1 over itai the itai. So mu will be equals to, if I integrate it, this will be negative ln itai, okay? So that you have mu equals, this negative goes up, so you have e ln itai like this. So this implies that my mu will be equals to, this will cancel this, so 1 over itai. Is that okay? So this is our integrating factor. So now our solution now becomes the integral of the integrating factor, which is 1 over itai. I've already used this formula before, times the q of x, which is, so the q of itai, this is negative 2 over itai the itai plus f of what? Xi, because we are integrating with respect to itai, so the constant becomes that. And the constant is not part of the integration here. This is a formula that I'm using over the integrating factor 1 over what? Eta. So for this case, let me clean the top one. So now we know that this 1 times negative 2 will be negative 2. So I can factorize that one out to get negative 2 out. Integral of 1 over eta times eta is eta squared the eta plus f of xi all divided by 1 over eta. But you know this 1 over eta is the same as negative 2 times eta. Okay. Now let's integrate this. If I integrate this one, I'm going to have negative 2 multiplied by negative 1 over eta. This one is divided by 1 over eta plus f of xi also divided by 1 over eta. Is that okay? Very good. So my u here is going to be this n will come and multiply this. Is that okay? So this n will cancel this n. Negative times negative will be positive 2. Plus this n will come and multiply this. So that will be n f of what? Xi. Is that okay? So this becomes a solution to it. But the question was given to us in terms of x and y. So we need to convert this one to what? X and then what? Y. Is that okay? Good. But xi was given as xy and eta was given as what? Y. So in this case, our u is going to be 2 plus y f of what? Xy. So this becomes our final answer. This becomes our final answer. Okay, so we should take note of some of these things when they pop out. Thank you for watching. Try to subscribe and share.